Hey guys, hope all is well. Hope everything's going good. Section 11.3 is what we're going to go over today, which is area of polygons. First, let's review some vocabulary and learn some new vocabulary. Remember from, I believe, chapter 7, I know it's been a long time ago, a regular polygon is a polygon in which all side lengths, get my pen here, in which all side lengths and all angles are congruent. Okay, so all the sides are the same length, all the angles are the same measure. All right, an apothegm, and give me a minute and I will draw a picture and it'll make a lot more sense of these next few vocabulary words. An apothegm is the distance from the center of the polygon to any one of its sides. And I should have put the regular polygon. Probably would have made a little more sense. All right, the center of a regular polygon would be the center of a polygon's circumscribed circle. It would be equidistant to each vertex. Once again, I will draw a picture here in a minute. The radius of a regular polygon is just the radius of polygon's circumscribed circle. And the central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of a polygon. All right, so what do these mean? Let me draw a picture. All right, let's draw a circle here. So here's a circle. Now, anytime we have a regular polygon, we can inscribe it into a circle. So it doesn't matter if it's a regular octagon, a regular nonagon, a regular pentagon, regular 85-agon, doesn't matter. We can always inscribe it into a circle. So I'm just going to, I don't know, I'll tell you what I'm drawing after I draw it. And guys, clearly my art isn't good. That's not a regular 1, 2, 3, 4. That's not a regular pentagon, but you get the idea. So here's my regular pentagon. We're gonna just imagine for a minute that it's regular. So the center of the regular polygon would be essentially the center of the circle. Okay, so that brown dot right there, that is the center of the polygon, along with the center of the circle. The radius of the regular polygon would also be a radius of the circle, so this would be the radius. Okay, or this, all the way around would be the radius of the polygon, which is also the radius of the circle. So the radius goes from the center to each of these vertices. Okay, so a pentagon would basically have 5 radiuses. Now, an apothegm, in some ways or in some places you can look and they pronounce it apothegm. It's the same thing. It is from the center, it's the distance from the center to one of its sides. Okay, and remember when we're talking about to the sides, we're talking about the perpendicular distance. So this would be the apothegm. And once again, for a pentagon, you would have 5 apothegms. Now, the cool thing about the apothegms is it actually divides this segment into two congruent parts. It bisects it. It's the perpendicular bisector of that segment, which will be important here in a little bit. All right. The equation to find the area of any regular polygon is this. So the area is going to be 1/2 times the apothegm times the perimeter. Okay, so it is important to know what the apothegm is. So 1/2 apothegm times perimeter. Now that works for any regular polygon, whether it be a pentagon, an octagon, a hexagon, a nonagon, a dodecagon, a 58-agon, a 117-agon. It doesn't matter. Any regular polygon can be found using this formula. It has to be a regular polygon. Okay, it only works for regular polygons. If it's not regular, you cannot use this formula, and chances are you're going to have to work a whole lot harder to find that area. All right, before we get to just area, let's talk about some angle measures because we will be doing a lot with angles to find things that we need to get that apothem in the perimeter. So here we have a 1, 2, 3, 4, 5. So we have a pentagon like I drew. It's ironic. So it said, oh, it tells me it's a regular pentagon, duh. It is inscribed in circle F. We want to find the angle measure of each of these angles down here, A, B, and C. So the measure of angle AFB. Okay, AFB is right here. I want to find the measure of this entire angle. Okay, well, this would be, think of this as like a central angle, right? It's a central angle of this circle. Well, now let's think about it. This is a regular polygon. How many central angles do we have? Well, here's one that we're trying to find. Here would be another. Here would be another. Here would be another. So there's 1, 2, 3, 4, 5. All the way around is 360. So we would find the measure of AFB by taking 360 divided by 5, and that gives us 72 degrees. Okay, so AFB, which is right here, is 72 degrees. Now I'm going to erase all this because we're going to need to see it a little bit better. All right, so now I want to find AFG. So AFG, well, that's just A to F to G. That's this angle. Guys, remember when we draw the apothem, and remember, this here is the apothem. I told you that it was the perpendicular bisector of each of the sides. Okay, so it's the perpendicular bisector. It bisects the side. It also bisects this big angle here. So basically what it does is it cuts this 72 in half. 72 divided by 2, 36 degrees. So that's 36. All right, let me erase this again. Oh, that was crazy. That's not what I want to do. All right, we still have the apothem right here. We know this is 36 degrees. All right, now we want to find GAF, angle GAF. So measure of angle G to A to F. So I'm talking about this angle here. Well, guys, notice this is just a triangle. We know this is 36 degrees. This is 90 degrees. So this would be just whatever 180 minus 36 and 90 is. So this would be 54 degrees. Okay, just know that the apothem is the perpendicular bisector. Also know how to find the central angle. And you will use that to find the area of a regular polygon. All right, here it is, guys. Just a forewarning, these are fun. By fun, I mean they're pretty extensive. Okay, so as you're taking these notes, please be taking them diligently. Don't just write down what I'm telling you. Take them and let it process. Pause the video if you need and let it process, and rewind it if you don't understand why I'm doing something or where I got something. All right, so a regular nonagon is inscribed in a circle with a radius of 4, and it tells us the radius of 4 right here. Well, nonagon has 9 sides. All right, we want to find the area of this nonagon. Well, remember, our area is just 1/2 times the apothem times the perimeter. All right, we don't have the apothem and we don't have the perimeter, and we have to do a lot of work to find both. All right, so the first thing we want to do is we want to find the central angle. So we want to find this whole angle here. Okay, so in order to do that, think of this as, well, how many of these pieces can I make? Well, if I were to draw here, here, all the way around, there'd be 9 total, because it's a nonagon, 9 sides. Therefore, that central angle, go ahead and write it, central angle is going to be 360 divided by 9, which is 40 degrees. So the measure of angle KLJ is 40 degrees. Okay, that's just one of the steps we have to do. Now, when I draw this apothem through it, it cuts it in half. It cuts that angle in half, it cuts that side in half. It is the perpendicular bisector of it. So that would mean that the measure of angle, I don't know, KLM, would be half of this 40. So 40 divided by 2, which is 20 degrees. Okay, so the measure of here is 20 degrees. Now, this is going to get pretty messy if I don't do something soon. So I'm just going to redraw this triangle bigger out here. So here's my right angle right here. This is my M, this is my K, this is my L. I know my radius is 4, and I know that this is 20 degrees. Okay, so once again, all I did is I took this triangle, get another color, this triangle right here, and I just put it down here just to give us something, a bigger picture that we can look at. All right, now let's find my apothem. Okay, well, if I go back up to the big picture, my apothem is right here. Well, that'd be the same as this, so I'm going to label it A for apothem. Okay, you guys are looking at this, you're like, well, we don't have two sides, can't do Pythagorean theorem. No, but we have an angle measure and a side, so we can use trig. Okay, so we'd let this 20 be our reference angle, which means this would be the opposite side. This is the hypotenuse. A is adjacent. That worked out nicely. Okay, so we want to find A, and we know our hypotenuse. So I'm going to look at SOHCAHTOA, and I'm going to say, okay, where does my A and my H mix together? Well, that would be in the cosine. So I'd say cosine of 20 degrees equals, well, cosine CAH is adjacent over hypotenuse. So adjacent we don't know. Over my hypotenuse is 4. Okay, now I want to just solve for A. So just algebra from here. So times 4, those go away. So 4 times cosine of 20 degrees equals A. And just put this into your calculator, but before you do, make sure your calculator is in degree mode. Very important. So when you put that into your calculator, you get roughly 3.76. So this is 3.76. So my apothem then is 3.76 times, we haven't found my perimeter yet. All right, now let's find my perimeter. We can't find the whole perimeter right now. What we can find is find a piece of it, okay? And that piece that we can find is right here, okay? That's a piece of the perimeter. All right, so I'm going to use trig again. This time I want the opposite side, and I still have the hypotenuse, so I'm going to use sine. Remember, so sine is opposite over hypotenuse. So I'm going to say the sine of 20 degrees equals opposite over hypotenuse. So I'm going to put an X rather than an O just so I don't confuse it as a 0 over 4. Okay, same thing here. Let's multiply both sides by 4. So 4 times the sine of 20 is going to equal X, which is my opposite side. When I plug that into my calculator, I get roughly 2.74. Nope, I don't get 2.74. I lied. I get 1.37. All right, so this here is 1.37. Now, that would be one piece. Remember, the apothem is a perpendicular bisector, which tells me that this piece is also 1.37. So 1.37, 1.37. So one side is going to be 2.74. That's where that number came from. Well, this is a regular nonagon. Regular meaning all sides are the same. Nonagon means it has 9 sides. We know the side of one, or the length of one side is 2.74. So that means the length of all 9 sides has to be 2.74. So 2.74 times 9 gives you 24.62. So that'd be this piece, and this piece, and this piece, and this piece, all the way around. Guys, isn't that the perimeter? And isn't the perimeter what we want? So times 24.62. So if I put this into my calculator, guys, I get roughly the area is about 46.3, and that's inches squared. This is about as hard as it gets, this chapter. All right, that's a lot. Watch this a couple times. Like I said, when you're taking notes, please make sure you understand each step and reach out if you have any questions. All right, one more example, and then we'll be good for the day. And these are super easy. Like I said, regular polygons are about as hard as they come this chapter. All right, so the area of a rhombus or a kite is 1/2 diagonal 1 times diagonal 2. So area equals 1/2 diagonal 1 times diagonal 2. Guys, it doesn't work with, it doesn't matter which one's diagonal 1 and which one's diagonal 2. Just pick one and go with it. Now, when I say diagonals, that means this is a diagonal and this is a diagonal. This is diagonal, this is diagonal. All right, so on A, 1/2 diagonal 1 times diagonal 2, this is just 1/2. 8 times 6. You could do 6 times 8, it doesn't really matter. Which is 1/2 times 6 times 8 is 48. That'd just be 24 meters squared. We're in area, so we square the units. And then same thing over here with this kite, guys. The area is just 1/2 times the 2 diagonals, so 7 times 10, which is 1/2 times 7 times 10 is 70. So it would be 35, and that'd be centimeters squared. All right, I believe that's it. Yes, that is it. You have homework online on Big Ideas Math, and then that's it for this week. Just 11, oh my gosh, I'm all messed up. 11-2, and then this is 11-3, and that's it for this week. So knock them out, get stuff done, and shoot me an email if you have any questions whatsoever. Talk to you later, guys.